Let's start now. Right. So, Surya, we have covered a little bit. You can go and see the recording. Okay, not much. You covered a little bit part of it. Okay, now let's understand what are. Okay, great. So now let's understand what are client-server systems. So if you look at the evolution of computing systems, right? Earlier days there used to be huge mainframe systems, and the mainframe systems used to carry out the complete calculation, and there are huge tape-based databases, right? And a small computer here somewhere. Okay, and this is how in one room one huge computer used to be there. This is 1960s and 70s. Okay, then came the era of client server, wherein what happened was, okay, you could have a lot of applications running on your server, and you can serve multiple clients. Now this is the era of web. Okay, so you had a lot of database tier, right? Application tier and a web tier. Okay, the web tier is with which the client used to interact, right? And the application used to process and database used to store. Now, if you look at client server architecture, it could be three separate servers also. This is your web server. Okay, this is your application tier, and this is your database tier, right? It could be three separate machines, it could be one single machine, but there is a demarcation, and today's systems also broadly work on this particular concept itself. Now, once and this is the major way in which all the entire web services in the internet are running. Now, what are the problems, right? So you have a client which is accessing your web application. So what happens is, you get certain information, you post certain information using HTML and HTML language. So you interact with the web server using the HTML protocol. Okay, and the HTML is the protocol which is understood by HTML, and JavaScript are the two languages that are understood by your browser. So browser communicates with the web server using HTML and JavaScript. Now what happens is, once you have this web application, right, and you have an application tier and you have a database tier, if you don't have basic security measures, your client can actually bypass and access the database directly. Okay, it can go and do certain funny things with your application, it can go and do certain funny things with your web itself. Okay, so that we will see how. So what happens is, if you go to a website called OWASP, Open Web Association for Security and Privacy, okay, OWASP lays down the top 10 web application vulnerabilities. Okay, and first amongst them is something called SQL injection. Okay, you should be aware that whenever you are trying to analyze the security of a web application, first thing you do is go to OWASP top 10 and see what are the 10 major insecurities or vulnerabilities in web-based systems. Okay, and if you go through those 10 vulnerabilities and incorporate that in your web application, your application will generally be secure. Okay, now what is the main concern? Main concern is, first is defacing of website. How do you deface a website? You run a script, and the script is accepted by your server at the backend. Okay, you push some code and it is accepted by the servers. What happens? The server executes the code and your website gets defaced. Such kind of attacks are called injection attacks, scripting attacks, wherein it is cross-site scripting. Okay, I've allowed a server to take a script which is not allowed. Okay, now you see all the web defacing applications. This is the most simple attack by which hackers do web defacing. Burger company got hacked, right? Hack was nothing but you are basically taking input from an unknown entity. And how do you protect it? Simply by validating, input validation. Is this command, is this script which I'm accepting for the client allowed? No, it is not allowed. Don't execute. Simple as that, right? Right. So these are the injection attacks. Injection attacks are generally prevented by input validation. What is it that I am supposed to take from the user? If it is username and password, I will take username and password. I'll not take a SQL command. If I take a SQL command, what will happen is SQL injection attack will happen. Okay. But the simplest way of protecting such is having secure coding principles and applying a simple web application firewall. Okay. Web application firewalls are very, very adept in detecting such attacks and can drop those packets. Okay. Then what happens is, at times, when you access a website, you have a lot of temporary files and cookies and caches which are stored in your browser. Hackers, they get access to these temporary files. If the browser is not saving them or protecting them, hackers get these temporary files and use those temporary files to launch a replay attack. Okay, that means they use those files and see whether they are able to get access to your session or not. And such kind of attacks happen, and they are called session hijacking. And that's why they say whenever you have a very critical application, please log out. Because if you're not logging out, your login information is there in a temporary internet file. Somebody might steal this temporary internet file and do a replay attack on your banking website or some critical website. And that's why banks auto log you out within a non-active session. The moment they say there is a non-active session, they automatically log you out. Okay. Right. Now there are certain systems which you should be generally be aware of. We are about to, reach probably the certain part of, we have almost covered a lot of ground. Okay. What are large scale parallel data systems? Large scale parallel data systems are used in supercomputing. Okay. If you look at the AI systems, they use large scale parallel data systems. What happens is you have multiple processors which are connected by a bus and a control unit. Data is fed directly. These are nothing but GPUs. And AI systems work on this particular methodology. It's called massive parallel processing. So you are processing a lot of data parallelly, okay, generally used for scientific computations. Okay, then there's something called grid computing. Grid computing is making use of multiple computers on a network to process some information. So if you have, say, in your organization 1,000 computers, and you know that you can make use of these 1,000 computers to achieve some kind of a server activity. Okay, so you create a mesh of these and create a control node. Now you can use certain computing power from all end devices and create a grid computing. Okay, a lot of scientific institutions carry out such kind of computing where they need immense amount of computing power. They create a controlling node and they ask volunteers to join their node, and then application resides on your endpoint and processes data for those scientific institutions. Generally, they are open architecture systems. Then there is a network called P2P. What is P2P? P2P is, there's a network between you and me. We have created one network. The problem is, the moment you create P2P networks, there is security concerns for privacy. I have a movie, I've shared it with you. So you remember the time of torrents? Okay, so there was a lot of piracy happening. We never bought a movie or never bought a song, right? We always used to download it using a torrent. So since internet speeds increase, now you see watching a movie or listening to music have become actually cheap, and you don't want to get into the pain of downloading a torrent. You can just listen to music for $120 on YouTube Music, per month. You don't mind paying, rather than getting into the hassle of downloading a torrent software. A lot of malware can come in. So what happens is, now because of high internet speeds and low cost of content, torrent is now more or less been rendered ineffective. But you should know what are the concerns. Now, one of the most important systems which are now coming into forefront are the OT systems, or operational technology systems. Now, what are operational technology systems? Now, what happened in the era of industrialization? What happened was IT systems got evolved separately. OT systems were the systems which were used in manufacturing. Okay. What was manufacturing? Say I have a supply line where a car has to be assembled. Okay. So a raw material will go from this side, a particular, on a particular thing, welding will happen. And on the particular bench, some automation, seats will get embedded, then something, tires will get, then painting will happen, and then finally the finished product will come outside. Okay, now this is called a production line, and a lot of automation took place where robotic arms were there. Okay, and this had a direct implication on total number of cars that would be produced, and there were such multiple production lines, right? Now these were connected, so there was a lot of machinery firstly, okay, and then they were connected using a network and a control unit. Okay, such systems had a network, but they had a proprietary networks. They were not using TCP/IP. So what happened over a period of last 20 years, these systems remained static and now they are obsolete. And now people are realizing that OT systems are now can ride on IP systems. So they created that, but that gave rise to vulnerabilities because these systems have almost lived their life and they were not built for security. They were built as independent systems. Okay, and that's why now the OT security has come into picture. Now, what is how an industrial control system works is there are three things in an industrial control system. First is the distributed control system. The distributed control system is nothing but, say I have multiple factories and production has to happen at the same time. So what will happen is one of the system will be a control unit and it will have subunits connected to different factories. Okay, so what happens, the control was distributed. So these were the distributed control system. And then you have a data bus, which is called the SCADA. So now, since you need to synchronize the activity, you had certain data buses, which were called SCADA systems. They could, process certain information and pass it to the final equipment, which was doing the work. Okay. Now, these were proprietary systems built by Siemens, ABB, Honeywell. Okay. And these systems were not worried about what is happening in the IT world. But certain components, like these control systems, had a Windows NT server. Today, Manish is not there. Otherwise, he would have told us. Okay. He is OT guy, right? So these systems were based on Windows NT, and these systems are still running in oil and gas plants and a lot of places. Now they are, since the system are old, they are replacing with these buses with IT systems. Okay, and what happens the moment they integrated with IT systems, because the erstwhile network has died down and you're now getting IT to control that network, the vulnerabilities of the internet comes and affects the system. And that's why you see power plant shutdown is now a possibility. Railway shutdown is a possibility, right? And finally, the SCADA system, used to control the final device using something called a PLC. A PLC is nothing but a small sensor which receives the input from the SCADA and tells the machine what needs to be done. Okay. Now, over the combination of these three things, that is the distributed control system, the SCADA, and the PLC, was totally called the OT system. Okay. Now, what has happened is the PLC is being replaced by the IoT devices. The SCADA systems are changed from SCADA systems to data processing systems, which are riding on the internet. Okay, or the SCADA systems are packaged inside IT systems, and the distributed control system has been taken over by TCP/IP networks. So that means your DCS inherits now the vulnerabilities of the TCP/IP network. Your SCADA systems get wrapped in TCP/IP headers, so it is also vulnerable, and PLCs are replaced by IoT devices, which are very small devices and has very, very limited firmware and can become vulnerable to a lot of attacks. Okay, so just be aware of industrial control systems is okay. Now, what are the problems with security issues with industrial control systems? They have lived their life. Okay, and since they have lived their life, now you cannot upgrade them, so they are running and running. Okay, there is no logging possible because they were not IT systems. They have physical access restriction. You cannot go near the systems. Okay, so it is very difficult to manage such systems. They're bulky, they are old, they are 20 years old almost, right? So this is as far as industrial control systems are concerned. Now, over a period of time, since the network has become very, very fast, distributed systems have come into picture. Now, if you see distributed systems today, a lot of your computing is distributed over the internet, okay, and controlled by some kind of a language. A simple example is DNS. Okay. Now DNS has got a root server, which has got all the data. Then it has got child servers, which it replicates based on the region. And whosoever is nearest to the whichever server, the query of the DNS is resolved there. Okay. And the entire DNS architecture is controlled by UDP oblique TCP at port 53. That means all communication happens at UDP or TCP port 53. Inherently, DNS was insecure. There were a lot of attacks which happened on DNS. So this is one example of distributed architecture. Now, a distributed architecture is vulnerable to attacks on the nodes. Okay. You might attack here. This might work, right? This might fail, but your other systems might survive. So it has good availability, but at the same time, the attack surface is pretty wide. Okay. Distributed systems generally work with something called a integrated definition language. There is some kind of a language which is shared amongst the entire distributed parties, and they understand that particular language. The most common application now of distributed system is SDN, software defined networks. Software defined networks are the networks which are used by the modern days ISPs to provide internet on your premise, and they can control the entire network sitting at a network operation center in Mumbai or some other place, right? So what are the problems? The problem is, they can be there could be eavesdropped, there could be, who is sitting and configuring this network. So the common issues of access control are the problem in distributed systems. You cannot actually the moment your network is distributed, you don't have control over so many distributed edges. In a centralized entity, you have more control, but in a distributed entity, you have less amount of control. Okay. Then there is something called high performance computing. High performance computing services are basically, if you look at what we saw, parallel computing system, high performance computing systems are backend systems which can be hired to have high computing needs. So today you can go to AWS and log in and can take high performance computing for some task which you require, okay, and pay for it. High performance computing architecture do not have an operating system defined. You push the operating system when you need it. Say if you want Linux, you can push Linux. If you want Windows, you can push Windows. If you want Mac, you can push in Mac. They are OS free, and that's why you can load operating system on real time. And that is the concept of real time operating systems. The real time operating systems are used in high performance computing to meet the need of a client whenever they need to push any kind of system. They also give you a wide array of architecture to process multiple kind of environments, whether Windows based, Linux based, Mac based, Unix based, NT based. So you can have a lot of systems. However, the computing architecture is ready to accept any kind of operating system. So real-time OS, basically I told you, real-time OS is pushed as and when it is required based on the application requirement. Okay, that is called the real-time OS. You need a particular OS to process certain applications. You push the operating system, process the application, and then flush the operating system out of the system. Okay. Internet of Things has become part of our daily lives. All devices have small embedded systems inside. This pencil is IoT device, our phones are IoT devices, our lights, smart lights. The problem with these devices is twofold. First is, since they are small, their firmware is not very nicely designed or not very securely designed. They are cheap systems. Anybody can launch a denial of service attack using a IoT devices. There are a lot of attacks which take place from IoT devices. Second thing is, you have encryption is a problem. Why? Because since devices are small, if you want to have small devices, your encryption will be a problem. However, AES-128 based encryption has been developed for IoT devices. What are the basic ways in which you protect IoT devices? You have network segmentation. You segment the network. You do not expose it directly to a vulnerability. right? You patch the systems properly, you do firewalls, you implement firewalls, and you do not use weak defaults. So whenever default systems are there, you go out of defaults and engineer what is required for a particular system. So if a particular port is supposed to be open, you only allow that particular port to work. Then came the concept of edge and fog computing. The moment cloud computing came, what happened was cloud data centers were, at the forefront. They were handling massive amount of data, and the edge devices were processing the information. Now, the distance between the edge devices and the cloud used to be very high. So if I'm watching a movie at Delhi and the data center is in Mumbai, there would be lag. So what cloud service providers did, they created fog edges, fog data centers between the main cloud data center and the edge devices. Okay. And for you, it is transparent. But what happens is it gives you a reduced latency. You can have real-time networks possible. Okay. Fog networks also are riding on 5G systems. 5G systems are supposed to integrate your IoT devices to your data centers and your edge data centers using 5G network. So what happens is you will have a lot of devices sizes coming small. Why? Because you have a very high processing in between. That is your at the fog layer, which is not visible to you. You think that it is happening at the cloud, but actually physically it is happening at a node which is much nearer to you. Okay. So this is the concept of fog devices, fog computing. Okay. A short question and then we'll take a short break. Okay, CISSP is an English exam. I can tell you that. Okay. It's got this information all is fine, good for learning, but it's an English exam. So, right. If you need a refresh, that means you're dynamic in nature. Static RAM, the data is static. You do not need a refresh.
Thank you for watching. Don't forget to subscribe our channel.